This is lesson 14, right triangle trigonometry. Now obviously this lesson deals with a right triangle, so let's start by discussing what the standard way to represent a right triangle is in terms of how it normally is labeled and therefore how we could use this in terms of trigonometry. So what I'm going to do is I'm going to start with a right triangle. And so let's draw one here. And obviously, since it's a right triangle, we have a right angle down here. Now, the sides are the first thing we're going to talk about. The sides are typically always labeled with lowercase letters. So I'm going to call this leg, this vertical leg here, lowercase a. The other leg, which is the horizontal leg, I'm going to call lowercase b. And then the hypotenuse I'm going to refer to as lowercase c. Now, all of you should remember that there is one famous theorem dealing with the lengths of the sides of a right triangle, and that is the Pythagorean Theorem. And that basically says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Or in terms of this picture right here, we've got c squared is equal to a squared plus b squared. And as I said, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now, so this is how we label the sides. Well, what about the angles or vertices? Typically, these are labeled in capital letters, okay? Now, not just any capital letters, but the same letters as what the sides are, only the capital version of it. For example, this angle on the left side here, we are going to refer to as capital A. And notice, this is opposite side lowercase a. And this vertex on the top, we're going to refer to as capital B. And notice that this angle is opposite side lowercase b. And finally, the right angle vertex, we're going to label as capital C. And again, notice that this is opposite the side lowercase c. So anytime we're talking about a right triangle, this is typically how we label it in terms of the sides and the angles. Okay, so now let's use our typical right triangle and discuss some basic terms of trigonometry. So what we're going to do is we're going to again start off with our typical right triangle. And we're going to label it the way we labeled it before. The angle is capital A, capital B, and capital C. And then the sides are going to be lowercase a, lowercase b, and lowercase c. Okay? Now, we're going to talk about three basic trigonometric ratios. Okay? Now, we refer to them as a ratio, okay? And you'll see why in a second. And the first of these trigonometric ratios we're going to talk about is sine. That's S-I-N-E. But we're going to abbreviate it as S-I-N. We're going to use a three-letter abbreviation for it, okay? So we'll talk about sine, not to be confused with sin. All right, now, what we're going to do is we're going to start and we're going to talk about angle A here, okay? And we want to know what the trig ratios are for angle A. Okay, so we're going to say the sine of A is equal to what? Well, the sine ratio is always equal to the length of the side opposite angle A divided by the length of the hypotenuse. Or in other words, this is equal to little a over little c. Okay? Now, again, this is in terms of other terms that other than these letters here. You might say that the sine of A is equal to the opposite. So let's just see if we can squeeze in OPP here. The side opposite divided by the hypotenuse. Okay? So sine A is equal to opposite over hypotenuse, or in the case of our special triangle here, it's equal to A over C. Okay, so that's the first trig function we're going to talk about, or the first trig ratio. The second trig ratio I'm going to talk about is cosine. Now we're still talking about the same angle, but cosine is a different ratio than sine. Now we're going to abbreviate this again through with 3 letters, and we're going to say COS for cosine. Okay? So we're now talking about the cosine of angle A. Now this is equal to, in the case of our special triangle here, it's going to be equal to the other leg of the right triangle, or namely B, divided by the hypotenuse, which is C. Or, in general terms, this is equal to the side adjacent to the angle divided by the hypotenuse. Okay? So we've got 2 trig functions. The sine of the angle is equal to the side opposite that angle divided by the hypotenuse. It's that ratio. The cosine of the angle is equal to the side adjacent to that angle divided by the hypotenuse. Now, notice when I say adjacent, I'm talking legs. I am not talking the hypotenuse. So in both these cases, the numerator of the ratio is referring to a leg, okay? And then the denominator is the hypotenuse. All right, there's one more trig ratio that we're going to talk about here, and that is tangent, T-A-N-G-E-N-T. But again, we're going to take and abbreviate it with 3 letters and abbreviate it T-A-N. Okay, and if we're talking about the same angle, so we're going to say tangent A. All right, so what is tangent A equal to? Tangent A is equal to, in the case of our special triangle here, it's equal to A over B. Or in general terms, it's equal to the side opposite the angle divided by the length of the side adjacent to the angle. Again, when we're talking adjacent and opposite, we are not talking the hypotenuse, we're talking the legs. So the tangent of angle A is simply equal to the opposite over the adjacent. The length of the side opposite the angle divided by the length of the side adjacent to the angle. Now, if you look at this, and you look at the first letters of opposite, adjacent, and hypotenuse, there's an easy way to remember what these 3 trig ratios are. And that is, we can use this term here, and that is SOHCAHTOA. And notice the way I'm going to spell it. S-O-H C-A-H-T-O-A. And in my class, I've often used the term that this is this famous Indian chief, okay, Chief Sokotoa. All right, now if you break this up into 3-letter segments, though, you can see SOH is simply sine is equal to opposite over hypotenuse, SOH. Cosine is equal to adjacent over hypotenuse, CAH. And tangent is equal to opposite over adjacent, TOA. So this is an easy way to remember the 3 trig functions and what their ratios are equal to in a standard right triangle. Okay, now let's talk about some examples using what we've learned so far. So let's start off with a triangle, a right triangle, and we're going to label the sides with actual lengths, okay? So I've got a right triangle here, and I'm going to say that this side right here is 3, this side here is 4, and the hypotenuse is 5. Okay, this should be a fairly common right triangle for you that you're familiar with, and I'll call this angle A over here. So I've got a right triangle, the sides are 3, 4, and 5. Now I want to know the 3 trig functions for angle A, the 3 trig ratios of angle A. So I'm going to start off by talking about the sine of A. Well, if you remembered what we were talking about, the sine of an angle is equal to the length of the side opposite that angle divided by the length of the hypotenuse. Or in the case of our example here, it's simply equal to 3 over 5. Okay? Because 3 is the length of the side opposite angle A, and 5 is the length of the hypotenuse. All right, well, what about cosine of A? So let's look at that. Now, if you remember, cosine of an angle is equal to the leg that's adjacent, the length of the leg that's adjacent to that angle, divided by the length of the hypotenuse. Or in the case of our example here, it's going to equal 4 over 5. Okay? So the cosine of A is the length of the side adjacent to the angle divided by the length of the hypotenuse. And then lastly, we're going to talk about our third trig function or trig ratio, and that is tangent. So the tangent of angle A, and if you remember, that's equal to the length of the side opposite the angle divided by the length of the side adjacent to the angle, or in the case of our example here, it's equal to 3 over 4. So here are the 3 trig functions for angle A. Now, there's a couple of special right triangles that you need to memorize because it's going to help you immensely in terms of trigonometry. Okay, so let's look at what these 2 special triangles are. And the first of these is basically, it's an isosceles right triangle. And these angles, this angle here is 45. And if the angle down below is 90, then this angle over here has to also be 45. So this is a 45, 45, 90 right triangle. Now, what's the ratio of the sides of a 45, 45, 90 right triangle? If you remember from Pythagorean Theorem, now obviously since these angles are both 45, we're going to say that the legs are both going to be the same, and we're going to just arbitrarily say that they are 1. So there's this, the vertical leg is 1, the horizontal leg is 1. If you use the Pythagorean theorem, it's very easy to figure out that therefore the length of the hypotenuse is going to be the square root of 2. So if you've got a 45, 45, 90 right triangle, the ratio of the leg, of the sides, are going to be 1, 1, the square root of 2. Okay? So it is going to be very helpful if you memorize that and remember that a 45, 45, 90 right triangle, the sides are going to be in the relationship of 1, 1, the square root of 2. All right. The other special right triangle is a 30, 60, 90 right triangle. Okay? And we'll say this angle down here is 60. We've got a right angle, so therefore the angle up top is 30. All right? Now, on this, if we arbitrarily say that, we notice we got 30 and 60 here. Let's start with the side opposite the 30-degree angle. Let's say that's equal to 1. If that's equal to 1, the hypotenuse is always going to be twice that value. So whatever the length of the side is opposite the 30, the hypotenuse is twice that. So that's going to be, in this case, 2. And the leg, which is the side, the other leg, which is the side opposite the 60-degree angle, is going to be the length of the side opposite the 30 times the square root of 3. And again, if you use your Pythagorean relationship, you can see that these values are correct. So that for a 30, 60, 90 right triangle, the sides are in the ratio of 1 to the square root of 3, where 1, the shortest side, is opposite the 30-degree angle, 2, which is twice the length of the shortest side, is the hypotenuse, and then the other leg is equal to the shortest side times the square root of 3. So you're going to find it is going to be very helpful if you memorize these two triangles, because by memorizing these two, you will automatically be able to give the exact values for all the trig functions of 30 degrees, 45 degrees, and 60 degrees by just using these relationships on these two special triangles. Now that is the end of the lesson for today. Now go on to work on the worksheet.